Hello, we are discussing about GATE 2014 ECE paper. Look at the feedback system shown and the Nyquist plot of G of S is also given. Which one of the following conclusions is correct? Whether the G of S, that is open loop transfer function, is all pass filter, or is it a strictly proper transfer function, or is it a stable and minimum phase transfer function, or the closed loop system is unstable for sufficiently large and positive K. Okay. So look at the feedback system. The feedback system is consisting of unity gain, unity feedback, so that H of S is equal to 1. G of S is treated as open loop transfer function and this is open loop gain, K means. And for this open loop transfer function, it has given the Nyquist plot. Nyquist plot is not encircling the -1 plus J0, that is this point. So it has given that one there are two poles present. Okay. One is at +1, the other is at -1. Open loop transfer function consisting of two poles. One is at +1, the other is at -1. So first, if you are looking at all pass filter function is to pass all the frequencies from -infinity to +infinity with equal gain, but with unequal phase. So output and input are going to be differed by phase angle, but not with magnitude. So output is same as input, but only there is a change in the phase shift, which is all pass filter function. So it is passing all the frequencies from -infinity to +infinity with unequal phase. So general transfer function of all pass filter is going to be equal to all pass filter transfer function is looks like S minus A divided by S plus A, where A is location of 0 as well as pole. Okay. So this is, and if you are going with magnitude of this transfer function is 1 because S is replacing with j omega, then j omega minus A by j omega plus A. J omega minus A divided by j omega plus A. So magnitude of this one, magnitude of transfer function is equal to square root of omega square plus A square divided by square root of omega square plus A square. A is the location. So it will be having a unity magnitude. So all the frequency components are amplified by 1. Okay. But phase shift of this transfer function, if you observe, this is tan inverse of imaginary by real, that is omega minus A minus tan inverse of, for pole, if you are writing it numerator, this is minus tan inverse of omega by A. This minus A, this minus can be taken out. So the phase shift can be written as minus 2 tan inverse omega by A. Even though all the frequency components are amplified with unity gain, but the phase is going to be gets differed, which is depending on the frequency. So phase shift is a function of omega. So there will be unequal phase shift between output and input for different frequency component, even though it has the same gain. That is the function of all pass filter. So from this transfer function, if you are drawing on the S plane, there is a 0 present at A and pole present at minus A. So this is transfer function of all pass filter. So it says there is a 0 on right half of S plane and pole on left half of S plane. They are exactly symmetrical, okay, with respect to j omega axis, but their magnitudes are going to be differed. That is, their magnitude means their value, this is plus A, whereas pole is at minus A. But here it has shown that one both are going to be poles only. Okay. So this is not all pass filter. Next, come for the G of S. Strictly proper transfer function. Generally open loop transfer function, okay, is going to be stable or unstable. It may be, even though the open loop transfer function is unstable, we can make closed loop system stable. Okay. So G of S is a strictly proper transfer function means even the open loop transfer function is also stable. If the open loop transfer function is also stable, then it is called a strictly proper transfer function, because whether G of S is stable or unstable, we can make the closed loop system stable. That you can study in the Nyquist plots. So G of S, if G of S is also having all the poles on left half of S plane, then it is called a strictly proper transfer function. Proper transfer function is nothing but all the poles are present on the left half of S plane. but the figure shows that one there is a pole present on the right half of S-plane. So B is also wrong answer. Now we move on to C option. G of S is stable and minimum phase transfer function. The requirement for minimum phase transfer function is for open loop G of j omega, all the poles and zeros must lie on the left half of S-plane only. Then only there is a minimum phase shift possible between output and inputs. So this is also wrong because there is a pole present on right half of S-plane. So G of S is not a minimum phase transfer function. The requirement of minimum phase transfer function is all the poles as well as zeros should lie. Poles as well as zeros should lie on left half of S-plane. So C is also wrong answer. Now move on to D. Closed loop system is unstable for sufficiently large and positive values of K. So obviously D is going to be right answer since A, B, C are wrong answers. But still we are going to discuss something about this one. Okay. Even though the G of S is unstable, by looking at this Nyquist plot we can say G of S is unstable because there is a pole present on right half of S-plane. So G of S is unstable, but you can make closed loop system as stable. That is what we will study from Nyquist plots. Nyquist criteria says that N is equal to P minus Z, where N is number of encirclements around minus 1 plus j0, because we are dealing with G of j omega, so that we should go for the minus 1 plus j0. Okay, around minus 1 plus j0 in counterclockwise direction. And next, P is number of open loop poles in G of S on right half of S-plane. How many number of poles are present on right half of S-plane including j omega axis. So that is, if you are going with S omega, this is we are going to consider right half of S-plane including j omega axis. This is the contour we are going to consider. So entire right half of S-plane including j omega axis. How many number of poles are present in the open loop transfer function? This you can get directly from the G of S, that says that when there is a pole present in the right half of S-plane. So for the given function it is P is equal to 1 and number of encirclements you will get, okay, around minus 1 plus j0. Since it is not encircling this minus 1 plus j0, okay, the encirclement is not covering minus 1 plus j0. So N is equal to 0. So N is equal to 0 from this Nyquist plot, and P is equal to from the G of S open loop poles you can get. Okay, there is a right half of S-plane, so P is equal to 1. Right hand side there is a pole on S-plane. Next, what is meant by Z? Z is number of roots of characteristic equation. Roots of characteristic equation is nothing but number of zeros of characteristic equation on right hand side of S-plane. Zeros of characteristic equation is same as poles of closed loop system. Remember that one, this is very important. Zeros of characteristic equation is same as poles of closed loop transfer function on right hand side of S-plane. So we are only considering the right hand side S-plane. So for stability, for stable closed loop system, what we require is there is no pole should lie on right half of S-plane including j omega axis. So Z is equal to 0 is expected. Okay, but Z, how do you calculate? Z is equal to N is equal to P minus Z. Z is equal to P minus N. P P value is 1, N value is 0. Just now I have stated. P value is 1 and N value is 0. So 1 minus 0 is 1. So it says that one Z is equal to 1. So there is a 0 present on right half of S plane in the characteristic equation. With respect to characteristic equation, there is a 0 present on right half of S plane, which is same as there is a pole present in the closed loop transfer function on right half of S plane. So there is a pole present for the closed loop transfer function. So system is unstable. System is unstable. If it has n circle like this, then okay, and the n circle must be in the counterclockwise direction. If the Nyquist plot is given this way, then the system, closed loop system, is stable. Remember that one. So for the given Nyquist plot, system is unstable as it is finding a one closed loop 0 to be present on right half of S plane. So the right option for this question is D. Thank you.